Hello everyone, myself Professor Chavan. We have started the third chapter from our 11th Science CBSE board for the subject physics. In previous lecture we have studied about the different types of motion and their definitions, or how we have to differentiate the different types of motion. Okay. Now in this lecture we are going to study the next topic from the third chapter, that is the frame of reference. Okay. Frame of reference. Now you will say, what is the frame of reference? Okay, so it is a very important knowledge in the physics to know the frame of reference. Okay, the frame of reference help us to study the physics at the higher level, because once we know about the position of any particle, or if we know about the state of condition of a particle, either it is in motion or either it is in a rest, then we can go for the further calculations. Okay, so in a frame of reference we have to study about the directions and some other components to know about the position of a particle. Okay, so in a study of a physics, initially we have to use some particular directions, like suppose east-west direction, north-south direction, or the up-down direction. Okay, so as per the location changes all over the world, it will be difficult to know the position of any object. If we are in India, and from the India, if from the Mumbai, if we look at, then the Delhi is in a north direction, but if we go to the America, the Delhi is not in a north direction. Okay, it is not in a north direction from the Delhi, but from the Mumbai it is in the north direction. So as per the location changes, the direction of the particular things changes all over the world. Okay, so suppose if we have some positions, like if we know about the directions, or if we have the one watch for it, then if we are having some particles and they are in a motion, then by keeping some frame of one point as a reference, we can go for the calculation of a change of position. Okay, so in that case, what is necessary, that there must be one point as a reference. Okay, we need one point as a reference, and if we don't have that point as a reference, then we cannot go for the study of the change in positions. Okay, so it will be difficult in a physics if we have to go for the knowing the position of any particle or any body available on the earth with respect to the current location. Okay, so for that purpose we have derived one system of particles. The system of axis is known as the Cartesian coordinate axis. Okay, for our convenience we have discovered the Cartesian coordinate system. Okay, so what is in a Cartesian coordinate system? Why it is known as a Cartesian? Because the scientist Cartesian has discovered it. Okay, and by using this Cartesian coordinate system, we can go for the universal acceptance, because if we change the location of our selves, then as per our change in location, the direction of the directions changes. Initially, if we are in a east direction, and if we change our position from our current position, suppose in lycée, then in east direction, in this direction there is not the east direction, there is the another direction. Okay, so to solve this problem, we are allowed to use, or we have accepted one system as the universal system, and that system is known as the Cartesian coordinate system. And this system depends on our regular universal directions, like the east west, north south, or the up down. Okay, so depending on these universal directions, this x axis, y axis, and z axis, that is the Cartesian coordinate system, depends. So what is in the Cartesian coordinate system? How we are going to use the Cartesian coordinate system? Okay, so in a Cartesian coordinate system, it is mandatory that we can allow, or we can take any arbitrary line as the x-axis. Okay, so in a Cartesian coordinate system there are the three axes: the x-axis, y-axis and z-axis. Okay, so in these three axes, what is the necessity that we can take the any line as the x-axis. We can take this line as the x-axis, we can take this line as the x-axis, we can take this line as the x-axis. Okay, but the next condition is important, that while taking the y-axis, it is important that the y-axis must be at a 90 degree to the x-axis. Okay, we can take any direction as the x-axis. We can take this horizontal line as the x-axis, we can take this inclined line as the x-axis, we can take this inclined line as the x-axis, or this vertical line as the x-axis, but it is considered that the second condition is the y-axis must be at a 90 degree to the x-axis. Okay, so y-axis will be at a 90 degree to here, at a 90 degree to this one, at the 90 degree to this one, okay, at a 90 degree to this one. Then if it is x, this is a y. If it is a x, this is a y. If this is a x, this is a y. If this is a x, then this is a y. Okay, and the third condition is very important again, that the z-axis is at a 90 degree to both the x-axis and y-axis. Okay, the z-axis is at a 90 degree to the x-axis and the y-axis. So in this case, how can we go for the z-axis? It is in this direction, or we can look at this as this is the z-axis. In this is the z-axis. In this is the z-axis. In this is the z-axis. Okay, it is at a 90 degree. It will always at a 90 degree to. Okay, this is the mandatory condition, that it is always, it must be at the 90 degree to the x and y axis. Okay, so what is the important condition in the Cartesian coordinate system? That we can take the any direction as the x-axis. Okay, we can take any direction, any arbitrary direction as x-axis. Then y-axis always at a 90 degree to x-axis, and third one is z-axis always at a 90 degree to x and y axis. Okay, so to get any Cartesian coordinate system, we must have to fulfill these three conditions. Okay, we must have to fulfill these three conditions to use any system as the Cartesian coordinate system, because after these are the conditions which have accepted all over the world. Okay, these conditions have been accepted all over the world, and if we are using here one Cartesian coordinate system, then if and accordingly we have pointed the positions of the particular points, then if you go in America and you are going to use the same Cartesian coordinate system, then in that case there must not be any difference, because the same system is accepted in America also, and they are using the same direction as the x direction, they are using the same direction as the y direction, they are using the same direction as the z direction. Okay, so accordingly we have to follow these three rules for considering any system as a Cartesian coordinate system. Okay, the any arbitrary direction can be the x-axis, then y-axis must be at the 90 degree to the x-axis, and z-axis always at the 90 degree to the x-axis and the y-axis. Okay, so these conditions must be fulfilled, and whatever the meeting point of all the three axes is known as the origin. Okay, this point is known as the origin. This is the origin. This is the origin. This point is the origin. Here again, this point is the origin. So why we have to consider this point as the origin? Because we can take that point as the reference. Okay, we can take that point as the reference. Suppose we have given some locations like x is equal to 5, y is equal to 10, z is equal to 15. Then we can note down these directions along the coordinates of the x-axis. Suppose here is the 5, here is the 10, and here is the 15. Okay, here is the 15. Then whatever the point coming here, that point we can locate as this is the position of that particular point. These are the three coordinates of that particular point. Okay, if we have given the x is equal to 5, y is equal to 10, z is equal to 15, then we can locate that point at that position. Okay, we can easily locate that point at that position because we know where is the x is equal to 5, y is equal to 10, z is equal to 15. Okay, we know about this location. Now, if we have to go up to particular location, suppose we have given the location of a point like x is equal to 2, y is equal to 3, z is equal to 4, then in that case, if we have to reach this position of a point, we have to locate this position of a point, then we can easily locate this. Okay, we can easily locate this. So if we have x is equal to 2, suppose this is the x, so here is the 2, y is equal to 3, and here is the 3, then z is equal to 4, here is the 4. So wherever the meeting point of all these, here is the point P, we can call it as the point P. Okay, so this is the location of the point P. Once we know about the coordinates, we can find out its location. Okay, so like this we are using this Cartesian system. Now in this, the reference point is the point of origin. Okay, the reference point is the point of origin. Now what is necessary that in a frame of reference is which body we are considering as the frame of reference. Here we are considering this origin as the one frame of reference, and accordingly we are going to check whether or where is the location of that point, or up to which point we have to go. Okay, up to which point we have to go. So depending on this, we can go for this location of that particular point. Okay, so in this, if we are having some location of some point, and if we are having the watch with us, okay, so in that case, if the observer is at the point of origin, okay, if the observer is at point of origin, and after some time, if he find the coordinates of the particular point, suppose after the 5 seconds, if this point is changing its position up to this, okay, here is the another point, then we come to know that the particle or that point is in motion. Okay, the observer is noting down some readings with respect to the time, and in that time, if he found that the location of that point has been changed, okay, location of that point is changed, then in that case he can say that the point is in motion. Or if after the 5 seconds, if he measure the location of that point, if it comes same as it is the previous one, that is x is equal to 5, y is equal to 10, z is equal to 15, then in that case we can say that the point is at rest. Okay, the point is at rest. Okay, so what is important here, we must have one reference point, we must have one permanent reference point, and with respect to that we can go for the study of the change in position of a particle, and on that study we can find out either that point is it at rest or it is in a motion. Okay, either it is at rest or it is in a motion. So once we know the directions, depending on their coordinates, okay, we know the direction depending on the coordinates. Here x is equal to 5 means in the x direction it is 5, y is equal to 10 means in y direction it is in a 10, in the z it is a 15. Okay, so we know the directions that in x direction it is 5, in y direction it is 10, in z direction it is 15, and accordingly we are checking the position of that point. And if we are having the watch with us, then with that watch, if we check the direction, if we check the position of that particle after the 5 seconds, then if we come to know that its coordinate has been changed, then we can say that that particle is in motion. And if its coordinates are same as it is, then we can say that that particle is at rest. Okay, so what is important here? The first thing important here is the point of reference. Okay, the first thing important here is the point of reference, and with respect to that point of reference, we can go for the study of the motion, the study of the condition of that particle, or study of the state of that particle, either it is in motion or it is in a rest. Okay, so if it is changing its position with respect to time, we have the one quantity. Okay, if the object is or the particle is changing its position with respect to time, then which quantity we have? We have the velocity. Okay, when the object is changing its position with respect to time, then it has covered some distance from its original position, and whatever the distance it has covered with respect to time, during that there is one quantity we are considering, it is known as the velocity. Okay, it is known as the velocity. Now if after the 5 seconds, suppose whatever the distance here, suppose this is the distance A, then after the 5 seconds, again if we count here, then it is at this location. Okay, now the position of the point is at this location. Then after the 5 seconds, again it is covering the same distance A. Then we can say that the point is with a uniform velocity. Okay, we can say there that it is with a uniform velocity, because whatever the distance it has traveled in 5 seconds, the same distance it is traveling in the next 5 seconds. If we count the distance after the same 5 seconds, if again it is coming as the A, then it is in a uniform velocity. But now if after the 5 seconds time, if we count this speed of that, the distance covered by that point, then if it is coming greater than A, suppose after 5 seconds it is at this point, and if this distance is greater than A, suppose it is a B, okay, if it is greater than A, then we can say that the point is in acceleration. Okay, we can say that the point is in acceleration. But how we can come to know about the point is in acceleration? Because we are having the two quantities, that is the direction, and the second one is the time. Okay, we have the direction, we have the location, and the second one is we have the time. So depending on the time and the direction, we can find out either the object is having the velocity or the uniform velocity, or it is in the motion or rest, or it is in accelerated motion. Okay, suppose after the same time period it is having the more distance covered, then we can say that the point is in accelerated motion. Okay, so from the one fixed reference point, we can consider that whatever the locations of that point after particular time, and if we know the directions of that point, then we can go for its motion. We can go for study of its state, either it is at rest or either it is at motion. Okay, so accordingly we can say that it is in a rest or it is in a motion. Okay, so we have this Cartesian system for our easiness. Okay, for our easiness we have this Cartesian system, because only on the basis of one reference point and we are having the measurement system of a time, on that basis also we can go for the study of the state of object, either it is at motion or it is in a rest, either it is having the uniform velocity or either it is having the accelerated motion. Okay, so if we know the directions of a particular point, and if we have the watch to note down the change in the direction, the change in the position, then we can go for the study of the different quantities like the velocity, acceleration. Okay, so whatever the reference point we are taking here, it is the origin. So that is the importance of the Cartesian system. Okay, that is the importance of Cartesian system. So behind all these things is a one frame of reference. Suppose a person is sitting in a room and he is observing the various things like the sparrow at the window, or he is watching the TV, or some from the window he sees outside that the car is moving or the aeroplane is flying in the sky. Then what is the frame of reference for that person? This earth is the frame of reference for that person, because and the position at which that person is sitting is the point of origin. Okay, that is the point of reference, and the frame of reference is all the universe. Okay, if he is looking at that sparrow in the window, he sees that the sparrow is in motion. Okay, he sees that the sparrow is in motion, but along with that sparrow, if he is also in a motion, suppose the sparrow is flying. Okay, suppose the sparrow is flying like this and the man is also running like this. So in that case, the person can't measure the change in position of that sparrow, because the person is also in a state of motion. But what is necessary, that the person must be at the state of rest for the observation, for the calculation of the change in position of the any body. Okay, for that purpose, the frame of reference is this total universe, and the person sitting at its one location is the point of reference. Okay, so accordingly he can go for the change in position of the particular things, and if there is a change in position of the particular things, then that thing is in motion. And if there is no any change in position, suppose he is looking at the TV, if he is looking at the table, then you can see that that table is not in a state of motion, because if he check the direction and the position of that table after the 5 minutes, after the 6 minutes, then also he come to know that the table is not changing its position. Then he can say that the table is at state of rest. But after 5 minutes, if he look at that sparrow, the sparrow will not be there, or the sparrow will be from window to the upper case of the window. Okay, so sparrow is changing its position. So on which basis he can say that? Because he is observing that sparrow from his position. Okay, he is observing that sparrow from its position. Now suppose there are a number of planets in this universe. Suppose the one person is at Mars. Okay, the one person is at Mars. Then if he is observing the earth, then in that case this total universe, the total universe is the frame of reference. Okay, the total universe is the frame of reference, and the point of reference is the Mars. Okay, because the person is at Mars, then he can say that the earth is in motion. Okay, suppose this is the earth, this is the Mars, the person is at Mars and here observing the earth. Okay, the earth is rotating. Okay, the earth is rotating. Then in that case, this is the Mars is the point of reference. This is the earth. and this all universe is the frame of reference. Okay, this all universe is the frame of reference. So person on the Mars is the one observer who observes the change in direction, who observes the change in the position of the earth with respect to time. If he is having the watch with him, he knows the directions with respect to x, y and z axis. Then he can say that at the 12 p.m. the earth is at this location, at the 1 p.m. the earth is at this location. Okay, because why? Because he is going to study the change in position of that earth with respect to the direction and the time. Okay, with respect to direction and the time. So at that point, this Mars is the point of reference, and whatever the universe available here, that is the frame of reference. Okay, because the earth is moving in the universe, so that's why the universe is the frame of reference. Okay, now if the person is sitting on the chair on the earth, okay, if the person is here now, okay, person is here now, now the person is sitting on this chair in the room on the earth. Okay, then if he try to observe the motion of the earth, so is it possible? Is this possible to try to observe the motion of the earth? No, because the earth is the frame of reference in this case, because the person is on the earth. Earth is the frame of reference and he is trying to observe the earth's motion. So it is not possible. It is not possible because the observer is at the frame of reference. Okay, observer itself at the frame of reference. There is no any change in the position of the frame of reference and the directions. He don't know about the directions now, so he cannot go for the study of the motion. But the person from the earth can study the change in the motion of the earth. Okay, the person from the Mars can go for this change in position of the earth. Okay, so what is important here, that there must be the availability of the frame of reference for the study of the change in position. And once we know about the change in position, we can go for the different quantities like the velocity, acceleration. Okay, so likewise, if one person is sitting inside the train, okay, the person is sitting inside the train, suppose this is a train compartment and the person is sitting here, then okay, the person is sitting inside the train, then after some time, if he observes that the earth's surface, if he observes that the earth's surface is in motion, how he can observe? Because the train is in motion. Okay, the train is in motion, so how he can say that the train is in motion? Because with respect to the earth's surface, he can say that the train is in motion. So when the frame of reference is the earth's surface, the train is in motion. But when the person sitting inside the train is keeping that train as the one frame of reference, then he can't go for the checking the motion of a train, because he can't observe the motion of a train inside the train. Okay, he is not able to observe the motion of a train when he is sitting inside the train. But when he keeps the earth's surface as the one frame of reference, then it is possible that he can find out the motion of a train. He can find out the change in position of a train, because if he is initially at the Pune is the one earth surface, then after he is in a Mumbai, then he can know that the train is now from Pune to Mumbai. So how much is the distance traveled by that train, or how much is the time required for the train to cover the distance? He can note down this because he is keeping the earth's surface as the one frame of reference. Okay, so what is important behind these examples, that one cannot go for the measurement. Okay, one cannot go for the measurement when he is at the frame of reference. But when there is something surrounding which we can keep as the frame of reference, then it is possible that we can go for the study of the change in motion or the change in position. Accordingly, we can go for the study of the different quantities. Okay. So that is the importance here. Now, depending on the change in position and the change in motion, the frame of reference is again divided into the two parts. Okay. The frame of reference is divided into the two parts. The first one is the inertial frame of reference and the second one is the non-inertial frame of reference. Okay. So the inertial frame of reference and non-inertial frame of reference. What is the difference between inertial frame of reference and non-inertial frame of reference? According to laws of physics, the frame of reference is divided into the two types, that is the inertial frame of reference and the non-inertial frame of reference. Okay, the inertial frame of reference. So what is the inertial frame of reference? So in an inertial frame of reference, we have to go for the speed of a particular object, the speed of a particular body. If the speed of a particular body is in a uniform motion, or the object or the body is at rest, or either it is in a motion but that motion is a uniform motion, then that body comes under the inertial frame of reference. Okay, that body comes under the inertial frame of reference. Means if a train is in motion, that train must be with a uniform speed of particular speed. Suppose it is with a speed of 40 km per hour, then how much is the distance traveled by that particular train? That must be with a uniform speed of 40 km per hour. Then that motion of a train will come under the inertial frame of reference. Okay, that motion will come under the inertial frame of reference. So when the object is in a motion with a uniform speed, with a uniform velocity, then that motion comes under the inertial frame of reference. Then the second type of frame of reference is a non-inertial frame of reference. Okay, non-inertial frame of reference. So in a non-inertial frame of reference, there is the consideration of the acceleration. Okay, there is the consideration of the acceleration, and we know when there is the acceleration, whenever there is the application of a force. Okay, whenever there is the application of a force, there is the acceleration. So accordingly, whenever we have to go for the study of the force, and whenever there is acceleration or whenever there is the accelerating motion, that motion of a body comes under the non-inertial frame of reference. Okay, that motion comes under the non-inertial frame of reference. The different quantities, the different situations of the physics comes under the different laws of physics, like the Newton's law, gravity law, or the laws of the force. Okay, so depending on these, we have to go for the non-inertial frame of reference and the inertial frame of reference. Okay, suppose we have one object and we have to cover a distance of 100 km, and the object is traveling with a 20 km per hour. Then how much is the time required for that object to cover 100 km? It will be simple. We know the formula. Distance is equal to speed into time. Okay, distance is equal to speed into time. So how much is the distance we have to cover? 100 km. Speed kitna hai? And then how much is the time required? You can calculate it as the time is equal to 100 upon 20. So it will be 5 hours. Okay, the time will be 5 hours. How we can come to know? Because we have some formulas in the physics. Okay, we have some formulas in the physics, and if all the formulas are applicable for the motion of the object, then that motion of an object comes under the inertial frame of reference. Okay, that motion of an object comes under the inertial frame of reference. Whatever the kinematic equations we are having, like the V is equal to U plus AT, or the V square minus U square is equal to twice AS, or the what are the different formulas we are having, that formulas comes under the inertial frame of reference. Okay, whatever the study we have to do in a physics, that comes under the inertial frame of reference. Okay, we have to study the physics considering the inertial frame of reference. Okay, we are having the different laws like the Newton's law, kinematics law, the motion law, force law, gravity law. These all laws must be fulfilled by that particular motion. Then and then only we can consider that object under the inertial frame of reference, and we have to study only by the inertial frame of reference. We don't have to go for the non-inertial frame of reference. Okay, suppose we are having one ball and we are standing in one railway compartment. Okay, suppose we are standing in one railway compartment, and initially the train is at rest. We are standing here. Okay, we are standing here, and if we throw a ball which is with a velocity of 5 meter, then within a 2 seconds it will cover this total distance. Suppose this is the 10 meter. Okay, suppose this is a distance of 10 meter. Then velocity is 5 meter per second. Then to cover a distance of 10 meter, it will get the time of 2 seconds. Okay, to reach a distance of 10 meter, it will require the time of 2 seconds. So initially here the train is at rest. And the laws of Newton, okay, the Newtonian laws can be applied here. Okay, because Newton's law gets applied here, or we can say here Newton's law gets followed. Newton's law gets followed. Then in this case we can say that when we throw a ball with a 5 meter per second velocity, then it will require 2 seconds to cover a distance of 10 meter. Now if we throw a ball and train starts its motion, okay, if we throw a ball and train starts its motion, suppose we are standing here in this compartment. Okay, we are standing here, and from this with the same velocity 5 meter per second, if we throw a ball, then at that instant train starts. Okay, so when we throw a ball, at that same instant the train starts. So what will happen there? Okay, this distance is a 10 meter. Okay, this distance is a 10 meter. Now when we throw a ball with 5 meter per second, then what will happen there? As we know, there is some force. Okay, there is some force on the train when it starts. We will get the jerk in a reverse direction. Okay, due to the inertia. Okay, due to the inertia we get the jerk in a reverse direction. So that inertia force will get applied on that ball, and the ball is not possible to reach up to that 10 meter. But instead of reaching the 10 meter, within the 2 seconds the ball will reach up to this particular distance only. Suppose it will cover only 8 meter. Okay, so here, and the time is 2 seconds again. Okay, so here in the same time period of the 2 seconds, the ball can reach up to the 8 meter only. So why it is happening? Why it is happening? Because when we throw the ball, the jerk gets applied in a reverse direction. Okay, when we throw a ball and the train starts, the jerk gets applied in a reverse direction, and due to that force, the velocity of the ball gets affected here, and due to that velocity the reverse velocity will gain by that particular ball, and due to that its velocity will get reduced, and it can cover a distance up to only 8 meter. It is not possible to cover a distance of the 8 meter. So in this case, what is happening there, the Newton's law, the kinematics laws not followed here. So in this case we can say that Newton's law, the Newtonian laws not followed. Okay. The Newtonian law not followed here. That is due to the reverse jerk. The reverse jerk will get applied. The motion of a train will get acquired by the ball, and due to that the ball is not possible to reach up to the 10 meter. Okay. So in this case the Newtonian law not followed. Okay. So this is one example of a non-inertial frame of reference. Okay. This comes under the non-inertial frame of reference. This is the non-inertial frame of reference. Okay. This is a non-inertial frame of reference. Now suppose we give name A, B. The third condition we will see. We are standing in the same compartment. Okay. We are standing in the same compartment which is having the length of 10 meter. Then if we throw a ball with a 5 meter per second and for a time of 2 seconds. Then if we throw a ball and the train is in motion, then what will happen? Whatever the velocity of a train, it will be greater than 5 meter per second. Okay, because the train is in motion. Now throw a ball and train is in motion, but suddenly applies the brake. And comes to rest. Okay, so when we throw a ball and at that instant the train applies the brake, but what will happen? The train is initially at a higher speed. It is at a 40 km per hour, 50 km per hour. Okay, so that higher speed will get acquired by this ball. Okay, that higher speed will get acquired by this ball, and due to this, what will happen? Within a 2 seconds, the ball will get up to this point, and it can go up to this point also. Okay, it is possible to cover a larger distance than this distance also. Okay, it is possible to cover a larger distance than this 10 meter distance also, because whatever the speed of the train, that speed will get acquired by this ball due to its inertia. And when the train applies the brake, due to the inertia, whatever the inertia of the ball, that ball will get thrown in a longer distance. Okay, that ball will get thrown in a longer distance. So in that case, what will happen? The ball is able to go longer than the calculated distance. Okay, actually how much distance it has to cover? Only 10 meter, but it covers the 15 meter, 12 meter, 13 meter. Okay, because only due to the inertia. Okay, only due to the inertia. Okay, so due to that inertia, and it acquires the speed of a train, and due to which it will get some larger distance. Okay, so that's why this motion of a ball comes under the non-Newtonian type of motion. Okay, so here again Newtonian law not followed. Okay, Newtonian law not followed, and it is the non-inertial frame of reference. Okay, it is the non-inertial frame of reference. Okay, so you will get the idea where is the inertial frame of reference and non-inertial frame of reference. Where is the inertial frame of reference? Where the laws get followed in the first condition. We have not written there. It is the first condition. In this, it is the inertial frame of reference. Okay, this is the inertial frame of reference because the Newtonian law get followed in this motion. Okay, the Newtonian law get followed in this motion, but here in this case, the ball get retarded, and in the second case, the ball get accelerated due to its inertia. Okay, here non-inertial frame of reference due to retardation, due to acceleration. Okay, so whenever there is the acceleration motion in any type of a motion, that motion comes under the non-inertial frame of reference. But when there is only uniform motion, then in that uniform motion, the Newton's law will get followed, and that type of motion comes under the inertial frame of reference. Okay, that type of motion comes under the inertial frame of reference. So in this case, the motion of the ball will get retarded due to the reverse jerk. Okay, and the ball acquires the reverse force. There is the application of the force in a reverse direction. So that's why that ball cannot get the required distance. And in the second case, there is the acceleration and the ball gets the higher distance than the required. So there is the accelerated motion. So whenever there is the involvement of the acceleration in any motion, that motion comes under the non-inertial frame of reference. And whenever there is the uniform speed, uniform velocity, that motion comes under the inertial frame of reference. Okay, so that's why we have to consider the frame of reference with respect to which we are going to consider the motion, with respect to which we have to find out the position of a particular particle. If there is a change in the position of a particle with respect to time, we can say that that particular point is in a motion. And if as the time changes but the position of that point will not change, its coordinates remains the same, we can say that that point is at rest. Okay, so this is the importance of a frame of reference. We have to study the different laws of physics by using this frame of reference, because the various laws we have to go study, like the Newton's law or the gravity law we have to study. Okay, then the friction laws we have to study. Whatever the laws we have to study, those all comes under the inertial frame of reference. Okay, there is no any consideration of the acceleration. So that's why whatever the motions which comes under the accelerated motion, those are under the non-inertial frame of reference, and whenever there is a uniform speed, that motion comes under the inertial frame of reference. Okay, so remember this inertial frame and non-inertial frame, that will be important for us for the next study of these chapters or the next chapters also, because whenever we have to apply these laws, we have to study the inertial motion only. Okay, that is the importance of frame of reference.